Dear students, welcome to Digital System Design using Verilog. In today's class, I will be giving you a brief introduction to Numeric Basics. So in Numeric Basics, we have to represent the numbers in order to process the data, which is one of the requirement in digital system design. So in what are the different ways of representing the number as unsigned integers, or it could be assigned integers. There are something called as fixed point real numbers, floating point real numbers, and complex numbers. So what are those unsigned integers? Is nothing but non-negative numbers including zeros, so which is used in real world for representation of the data, for example temperature, position and time. So there is no negative temperatures, there is no position like negative positions and all. So also it is used in controlling operation of digital system, like counting the number of iterations, table index. So unsigned binary representation, which is analogous to decimal representation. Let us see the representation of these numbers. So in decimal, as you already know, that it is base 10, so 124 to base 10. So this is what the representation. In binary it is base 2, so this number is in binary, which is represented in base 2, which is an equivalent to 124 in base 10. So generally a number x can be represented using n number of bits as x n minus 1, n minus 2 up to x naught, right? So that is about binary representation of the numbers. So unsigned binary is nothing but usually whatever the number we are going to consider, if it is n bits, we are going to represent that from 0 to 2 to the power of n minus 1. 0 is all zeros, 2 to the power of n minus 1 is total number of bits that we have considered. Altogether we need log n to base 2 number of bits to represent that. So 8-bit is nothing but a byte. 0 to 255 will be made use in the computers. 32-bit, like that 64-bit can also be made use by the computers for the representation of these binary numbers. After these binary numbers, we have signed integers. Unsigned integers is what we have seen over there. Now it is signed integers. How do we make use of these signed integers in Verilog? This is another type. So wire signed of 7 down to 0 a. So a is a 8-bit vector which is of type signed. Similarly, b is also a signed vector of size 14 bits. Totally it is of 14 bits. So 13 down to 0 is 14 bits. So it is possible for us to convert between signed and unsigned interpretations. In the previous slide what we have seen is unsigned integers. Here it is signed integers. You can see over here wire signed of s2. Similarly, dollar signed is a task that will be done by the system. So unsigned is also represented over here. Like that, signed, unsigned, signed are the two different representations. Next is about fixed point numbers. So most of the computer applications require the number to be represented in fixed point. Okay, so it will make use of non-integers, especially in the signal processing application. We have to go for this fixed point numbers, which is nothing but it allows the fractional parts to be represented in the numbers. So in terms of powers of 2, it can be an unsigned or it could be a signed number. So let us see an example of what is an fixed point number is all about. So in decimal it is 10.24 to base 10. So it is represented over here. As you can see that powers are in negative numbers for the decimal values. So otherwise it is a normal decimal representation. In binary, you can see that negative powers has been given to 2 to represent the number. So we are going to represent these numbers as per the convenience. So that is what fixed point numbers are. Again, in this there are unsigned fixed point. So if n bit unsigned fixed point is there, so m bit before and f bits after the binary points. Okay, so m bits before is like 10 is like m bit, 0.24 is like f bits. So after binary is taken as f bits, before it is m bit. So x is equal to x m minus 1 2 to the power of m minus 1, like that it continues until x minus f 2 to the power of minus f. So range and precision of this is given over here. Other than this, we have another way of representing the numbers, which is nothing but floating point numbers. Previous slide we have seen fixed point, now it is floating point. Scientific notations are done with this kind of floating point numbers, where you can see the decimal point, which is a mantissa, radix, exponent to that radix is given over here. So this is a floating point representation of a number. So s is nothing but sign, either it could be 0 or 1. 0 is non-negative, 1 is negative, and it is followed by exponent, e number of bits, and mantissa of m bits. So this is a floating point representation of the number. And so finally, as you can see that we have understood signed numbers, signed, unsigned, floating point, fixed point are the different types of numeric representation that can be done in digital system. So computers will make use of these kind of numeric values for the processing.